I also see a lot of opportunity here. Imagine if we had the ability to develop a million years worth of human evolution in one generation. How incredible would that be? Now, are we ready for it? I don't know. Are we ready for the weapons that we have and use against each other? Probably not. But here we are.
I think we've come very, very close to understanding the physics of how it works, and that's very exciting. That is for the first time we have a very compelling picture that what we are seeing is absolutely explained by our current understanding of physics and advanced physics and quantum mechanics.
Thank you for your work. Fascinating information you're getting here. I'm hearing a lot of good things that could possibly come out of this on the findings. I hate to be the doom and gloom guy, but I got to ask the question.
Sure.
What if this is something that can go wrong? These abilities that you seem to be capturing here, the potential for these abilities that seem to be outside our normal physics. Mm-hmm. If this is something that we would have to defend ourselves against, what's worst case scenario?
Well,
Have you thought about it?
I would tell you already, it's too late because it's here. So we have a choice. We can live with our heads buried in the sand and hope it goes away, or we can take our head out of the sand and try to figure out how it works. But whether we choose to accept it or not, it doesn't care. It doesn't really care what we think in this room because it's here. So whether or not we choose to accept it, well, I don't know what to tell you. No offense to anybody, but if you really think the earth is flat, I don't know what to tell you. In this particular case, it's here. So I think this is not like a discussion of fine wine. This conversation doesn't get better the longer we don't talk about it, right? The longer it ages, not a good idea. In fact, we should have had this conversation 20 years ago, 30 years ago, and we should have been a little bit more open about it, so we wouldn't be where we are here today.
And so for the first time now, particularly in the last few years, we now have the mathematical formulas and the scientific modeling, and then also the observations, electro-optical data, etc., all finally coming together, pointing in the same direction. So originally, our focus was trying to figure out what these things were and how they worked. And unfortunately, I don't think we're really much closer to knowing what they are. But I'm very excited because we just about figured out how they work, in our opinion. It's very, very compelling. And I think in the last 2.5 years, more has been done in this area. At least from our perspective, the government perspective. I can't speak on behalf of the private side, but from our perspective, I think we have a much better understanding now than we did just even 2.5 years ago, to the point where we are actually able to replicate some of this physics in a laboratory. So when we started this project, a lot of folks were concerned that maybe we were dealing with science fiction. And as it turns out, we're dealing with science fact. And maybe what some people considered fringe science just turned out to be advanced physics and quantum theory. So we've come a long way, and I think that's exciting news. Question number 3: do I believe we are close to understanding how they work? Yes. Yep. We are really, really close. In fact, I would submit to you, I don't think we are thousands of years or even centuries away. I think, based upon my experience, we might be 20 years out. It's no longer a theoretical question of if it's possible. We have already demonstrated the physics with the CERN, the Large Hadron Collider, and some of these other places where we know absolutely some of the physics behind what we are seeing is not only possible, we're replicating it. We're replicating it, though, at a very small level. But the question of whether or not can it be done, that's not a question anymore. It is being done right now. The real question is now, it's a technological challenge. It's a scalability issue. How do we replicate and control what we can see now in the laboratory in the very small scale, and make that useful to us in everyday life, in the scale we live in now?
science. Scientists now think that a single technology explains the amazing things these craft can do.
We do believe that now, for the first time, perhaps all these observables that we've been seeing, for example, sudden and extreme acceleration, hypersonic velocities, low observability, at transmedium travel, and last but not least, positive lift, or anti-gravity, is really a manifestation of a single technology. So it's not 5 exotic technologies we're trying to figure out how it works. It's one. And we think we know that one too.
One of the scientists who helped figure it out is physicist Dr. Hal Puthoff. He wrote the proposal that helped Bigelow land the contract to study UFOs, and in a recent radio interview said he commissioned 38 scientific papers during the study to explore exotic propulsion ideas, including what he calls space-time metric engineering. In essence, the gimbal and tic-tac craft were able to create their own space-time bubbles.
We believe that it has to do with a high amount of energy and the ability to warp space-time, and not by a lot, just a little.
That they have a general good idea of the physics behind these things and how they work.
I think it's safe to say that the leading theory is that all these observables, until we were trying to find the different exotic technologies that could explain that. It may very well be tied to the manifestation of a single technology. And if you have that technology and understanding of physics, all these observables are possible. I guess if there was any silver lining to this incredible enigma, is that we're beginning to realize that the physics, although advanced, aren't really breaking the laws of physics at all. They comport quite nicely to some of the models we see in quantum physics, and that ultimately, at the end of the day, these things, this phenomena, is still obligated to the laws of physics as we know them. They're not breaking the laws of physics. There just seems to be an understanding of quantum physics in a way that we haven't yet successfully been able to apply. Specifically as it relates potentially to Einstein's space and time. We now recognize that there are ways. Look, Mother Earth does it herself. Massive objects will warp space-time. We're all used to Newtonian physics. At the end of the Renaissance, Sir Isaac Newton proposes the physics that we're all very comfortable with: gravity, apple falling from a tree, force equals mass times acceleration, et cetera, et cetera. And then, of course, last century along comes this guy with crazy hair named Einstein, who proposes that there's actually a different model for the universe. And in fact, that Newtonian physics is true. There's an overlaying physics called relativity, where space-time is actually connected. They're not separate. And that space-time is flexible. You can compress it and you can stretch it. And in fact, mass does it. Mass perturbs space-time. And then, of course, 40 years ago, really, quantum physics begins to really come out and rock science on its heels. And the old analogy where you have this box and in walks a dog and out walks 2 cats 5 minutes later. And yet that's exactly what we're seeing with quantum physics. And it turns out that quantum physics has some very elegant solutions for perhaps some of the observables that we're seeing as it relates to the phenomenon.
Okay, so it's not like the light years away, technology that is thousands of years ahead of where we are now.
No, I don't think so. I think most scientists would agree that we're probably, at most 100 years, maybe significantly less. It's not that far away.
From what?
From being able to replicate that technology at a macro level.
So you're saying
at a usable scale.
Humanity as a whole could be, would be, will be replicating and using the technology observed in UFOs in their own lives?
I think, well, again, potentially within 100 years. There's people out there that will comb through every word I say and say, aha, see, he said this. So, I'd rather be a little conservative on the assessment, but given the current arc of our development and what we're doing and what we're learning and the advancements at the CERN Large Hadron Collider and whatnot, I think we're probably, within certainly a few generations.
Are you allowed to speak about, I spoke to Dr. Eric Davis, and one of the things he talks about is the warp bubble. And
That's right.
Okay, so, these things don't break the sound barrier essentially because they're not compressing air. At least what he says is that there is a warp bubble. Is that something you're familiar with?
I am. I'm certainly no expert. I am not a astrophysicist. My background is in science, but more in the biological areas.
Did it come up that these things could be traveling inside, essentially, using warp bubbles?
Yes. Let me just in the vernacular warp bubble, but there is a delta within the localized space-time construct compared to the external environment, in which a lot of the observations we see as seemingly extraordinary really aren't. They're rooted in some of the relativity principles that Einstein proposed, and that if you were inside this bubble traveling, what appears to us this incredible capability to maneuver at hypersonic speeds and instantaneous acceleration, and yes, even low observability. In fact, if you were inside that bubble looking out, the rest of the world will be going by in slow motion. And so it's not really, it's this weird duality where both are actually occurring, both our existence in this time and the relativity of being in this localized environment where you are insulated, where the way we experience space-time is there's a delta. It's different.
Warping space-time is something we see in the natural world all the time. So we see with GPS satellites. In fact, the GPS satellites right now, everybody has on their phone, I'm going to see where I'm at today. Those clocks have to be calibrated and recalibrated, even though those cesium clocks on those satellites are exactly the same as the ones we have on the ground station. They have to constantly be calibrated. And the reason why is because the effects of Earth's gravity has on the space-time of those cesium clocks here on Earth relative to those cesium clocks that are on those platforms that are above Earth. In fact, the clocks that are above Earth compared to the ones on Earth are running slightly faster. Now, how is that possible if they're the exact same type of clocks? Well, that is because the effects of Earth's gravity, the closer you are to a massive object, the more space-time is warped. And we've seen that with Einstein's relativity. And it all boils down to E equals mc squared, basically. What we're talking about is lots of mass or lots of energy to warp space-time. The closer you get to a supermassive object like the sun, the greater that distortion occurs. In fact, when you get to a black hole, time is so distorted that time stands still. So we've seen this. We've seen it with gravitational lensing. When we're looking at a far distant galaxy, we can see the effects gravity has on space-time. We can actually see it with our eyes. So we don't have to prove that. That is science fact, not science fiction. So the question is, technologically, how can we go ahead and manipulate that physics to our benefit? So now we can potentially warp space-time in a way that allows us to go from point A to point B a little faster. The question is no longer an if question, it's a when question.
George Knapp, 8 News Now.
Lue Elizondo confirmed that special materials would likely be needed to manipulate space-time.
I think the government knows something's going on, but they don't know what it is. And do you think we're closer to knowing what it is than in the 1940s?
Boy, that's a loaded question. I'm damned if I do, damned if I don't answer that. Here's my thoughts. I'm not sure we're closer to knowing what it is, but I do think we are potentially closer to understanding some of the physics involved. When I was part of the AATIP program, our focus was really very simple. What was it and how does it work? And I've said before, probably my greatest frustration is that we really still, at the end of all those years, didn't really know what it was. But, on the bright side, we were able to begin to peel away a little bit of the onion
with the 5 observables, and then be able to look at some of the new models in quantum physics and mathematical formulas. And it appears that that science, what we thought was so far off, and our understanding really isn't maybe quite that far away. And I think for me that was probably one of the greater accomplishments. And let me preface this by saying, it's not that we invented new physics. Physics, you don't invent physics. What you do is gain a better understanding of existing physics. And I think that's what we were able to do to some degree, is be able to, now that we have a little bit better understanding with some of our observations in quantum physics, be able to start developing models to see if they fit. And it turns out that some of them do. And every day we're learning something revolutionary in the way of science. And for us to think that space-time, in order for us to go to point A to point B, has to be some sort of linear function, we're beginning to realize that that's not necessarily the case. Quantum physics shows that space, to some degree, is rather irrelevant, and maybe even time to some degree. When you look at notions such as quantum entanglement, something is going on, this spooky action from a distance, if you will, where things are able to communicate with things, if you want to call it communication, act upon other things, where distance doesn't seem to be a factor. It's happening instantaneously and across the vastness of the universe. And so I think we need to be very careful. Anytime we shrug off the notion that there's new physics to be discovered, if you will, I think that's short-sighted, because one thing we've learned over and over again through time is that we haven't learned everything yet. And what we are seeing is real, whatever it is. So therefore, something or someone has been able to master a particular part of physics that we don't quite yet understand. I mean, that's evident.
But the skunk works. He said that it's possible we could, send ET home at this point. I mean, do you think there's any viability in what the technology is? This is another speculative question. What our technology is that we don't know about at this point?
Well, we don't know what we don't know, right?
Yeah.
So we can speculate all day long. I think one thing that we can certainly recognize is that science, our understanding of science, continues to evolve and evolves quickly based upon observations, and things that we thought were impossible in the past, we continue to prove ourselves wrong. There was a time where we never thought we'd break the sound barrier. There was a time where we never thought we could make the quarter-mile run in less than 4 seconds. There was a time where
4
we
minutes.
thought that, well, that 4 minute was running. I'm talking quarter mile with a drag race car.
Oh, okay.
NHRA.
Sure.
Sorry, I'm a gearhead, right? So my days of running are over. I only run when I'm being chased. I prefer gearhead talk, so I apologize. But there was a time where people thought we couldn't, all the things that we have been speculated before that we would never be able to do, we've been able to do. And we prove ourselves wrong constantly. So if there is one thing that I think we can say conclusively is that we definitely don't have all the answers yet, nor do we understand physics and nature yet as much as we'd like to think we do.
As far as the UFO, as far as UFOs, the study of UFOs, do you think it's possible that any of our adversaries may have more information on what these things are than we have? And it also makes me wonder why we don't unify in a situation like this.
Martin, therein lies the real issue for me, that we have a preponderance of evidence that suggests other countries are looking into this phenomenon, and they may even possibly have a better understanding than we do. If that is the case, then he who gets that match first wins. That type of technology in the hands of an adversary, could make the atom bomb look like a firecracker, and that concerns me, because we're sitting on our laurels, and we have allowed stigma and taboo to paralyze the conversation.
and while other countries are taking it rather seriously. And that is a concern for me. And now, does it have the potential to unite? I sure hope so, because otherwise it's not going to be a very good day for humanity. I think it should unite us. I think we should find some commonalities here, and rather than focus on the 10% of differences that we have with other countries and other nations, maybe we instead focus on the 90% that we have in common.